Hi everybody, this is LoveVFX and welcome to another LoveVFX tutorial. In this video I'm going to talk about how I created the 3D scene for my project Dropzone in Houdini Solaris, which I rendered with V-Ray. You can also watch the Nuke tutorial for this project on LoveVFX. I'll leave the link to it in the description of this video. Let's have a look at the trailer for this project to see the final shot. Before I continue, I want to thank the people at SideFX, Foundry, Chaos, ActionVFX, and the Pixellab for supporting me with this project. I also need to mention that this is not a beginner or step-by-step tutorial. I will talk about the most important aspects of the creation of this project and provide you with the links to the tutorials that I needed to watch in order to finish this project. A special thank you goes out to Alex and Gosho at Chaos, who answered some of my V-Ray questions. Thank you guys. I really appreciate your continued support. I want to divide this video into 3 parts. The first part is about the elements of the shot. The second part is about how I put these elements together in Solaris. And the third part is about how I rendered the shot with V-Ray in Solaris. Now let's take a look at the elements of the shot. First we have the environment at the top, which is mostly made out of a Kitbash 3D kit that is called Warzone. Then we have the missile with its smoke trail and the explosion of the missile. I bought the 3D model of the missile online, and I created the trail and the explosion with the help of 2 tutorials. You can find the links to the tutorials in the description of this video. Here you can see the animated dropship and the thrusters. I also bought the 3D model of the dropship online, but I retextured it in Mari. Then we have the ground dust FX simulation, which I received from the Pixellab. The Pixellab is an awesome website where you can buy high-end FX simulations. Here you can see the camera. And at the bottom of the snow tree, you can see the lighting and rendering setup of this 3D scene. I rendered this shot with V-Ray, but I'll talk about that in a moment. Now I'm going to talk about how I put all of these elements together to create this 3D scene. From the beginning of this project, it was my plan to create a scene with the help of a Kitbash 3D kit. They have an awesome software which is called Cargo that helps you to import their assets into your 3D program of choice with the shaders for the render engine of your choice. If you want to use such assets to create an environment with them in Solaris, it is a good idea to convert them into USD files that have a proxy geo, so you don't run into performance issues when you are using Houdini's layout node in Solaris. Normally you would use the component builder to take a geo, create a proxy of it, and apply the materials to it. But since you get finished assets from Kitbash 3D that have a huge amount of materials already applied to them, you can use another workflow. Here is how I converted my Kitbash 3D assets to use them with Houdini's layout node. First of all, you need to install the Cargo app and the Cargo plugin for Houdini. You can get that software on the Kitbash 3D website. Once that is all installed, you need to open the Cargo app, open Houdini, and connect Houdini with the Cargo app. And then you can go to the kit you purchased in the Cargo app. Here you can select any asset you want to import and press the import button. After just a few seconds, you can see this new node that popped up in Houdini's object level. You would do that with all of the models in your kit. Then you can copy all of your models, go to the Solaris stage, create a sub-create node, go into the sub-create node, paste all of your models in here, and now to save some time, I will show you a sub-create node that I created for this project. So as you can see, I imported all of the models in my kit, and here I created a box as a proxy for the building geo. Then I converted that into polygons, and then I created two name and two attribute create nodes, and merged them into one output. Let me show you how these name and attribute create nodes are set up. In the first name node, you have to write geo/render in the name field, and in the second name node, you have to write geo/proxy in the name field. Both attribute create nodes have to be set to a primitive class and a string type, and the name fields have to be set to purpose. On the original geo side, you have to write render in the string field, and on the proxy geo side, you have to write proxy in the string field. Then you have to go back to the stage, go to the Import from Sobs tab, and then to the USD Custom Attributes field and write the word purpose into it. And then you have to go to the Materials tab of your sub-create node and click on the Autofill Materials button. Now you can save your geo as a USD file with its applied materials and a proxy geo with a USD ROP node. And this is how your scene can look if you have saved your assets this way. I did this proxy conversion of the geo after rendering the scene, and that improved the performance of the scene a lot. In this USD asset subnetwork, I exported other assets like the ground, the road, and the mountains with the component builder. I used Kitbash 3D materials for all of these assets. The mountains are created with height fields. I learned how to create them by watching a tutorial. You can find the link to that tutorial in the description of this video. Now, I'm not going to talk about the usage of the layout node in Solaris, because there are enough tutorials online that can help you with that. And for me, the most important information here is you need to create very low poly proxies for the USD assets you want to scatter to optimize your scene and make it all run faster like I showed you. Alright, that was it for the environment. In the next section, we have the animated missile with its trail, a light, and the explosion. I bought the missile geo on CG Trader, created the trail and the explosion with the help of two tutorials, and animated the missile, the light, and the trail here in Solaris. I'll leave the links to the tutorials for the trail and the explosion in the description of this video. In the next section, we have the hero asset, which is the dropship. I bought that asset on CG Trader too, but I retextured it in Mari. I added the tutorial trails to it for the thrusters and put lights in the trails, just like I did for the trail of the missile. And I did the animation of the dropship in Solaris too. Unfortunately for my PC and my electricity bill, putting lights in VDB simulations and rendering them with V-Ray wasn't such a good idea, because it took ages to render the shot, 1 month to be exact, and I ended up recreating the thrusters look in comp anyways. Once I removed the trails from the scene, the performance gets a huge boost, and V-Ray renders the image in the viewport instantly. That was it for the dropship. In the next section, we have the ground dust VDB simulation, which was given to me by the wonderful team at the Pixellab. As I mentioned earlier, the Pixellab is an awesome website where you can buy high-end effects simulations. Whenever you are dealing with VDB simulations in Solaris that you want to render as a deep render with V-Ray, it's important to enable the volumetric geometry mode in the volume grid shaders rendering tab. I did not render this shot as a deep render, but it is still good to know. In the next section, we have the camera, which I will not say much about, but I'll give you a quick summary of how I animated it. First of all, I created a car simulation in Houdini Indy 20.5 with their RDB car rig. Then I constrained the camera to the car, used the motion of the car for the animation of the camera, and added additional animations to make it look at the dropship. It was a really complicated workflow that I used because it involved so many layers of animation. But in the end, I think it made the shot look more realistic and exciting. Alright, now I'm going to talk about the lighting and rendering section of this project. The lighting setup is very simple because I just used a dome light and a distant light as the main lights in the scene. In the dome light I used an HDR from Polyhaven, which is called Overcast Soil Pure Sky, and I used it as an overall ambient light. I used the distant light as my sunlight, and I created 3 light groups. One for the dome light, one for the distant light, and one for all of the thrusters and trail lights. The light groups turned out to be very important in compositing, but more about that in the Nuke tutorial of this project. Here's how you can create a light group with V-Ray for Solaris. First of all, you need to have a light. Then you can select it, go to V-Ray's LPE tab, and give your LPE tag a name. Then, in the V-Ray standard rendervars node, in the LPE tab, you can see how I created the light group for the dome light, and that was the same way I created the other 2 light groups. I had a problem with V-Ray's beauty layers, but I fixed it in comp. The problem was that they were not matching with the rendered beauty layer, but I will talk more about that in the Nuke tutorial of this project. If you want to know how to set up a render with V-Ray for Solaris, you can take a look at my V-Ray for Solaris tutorial. I'll leave the link to it in the description of this video. The short explanation is, in order to render your scene with V-Ray for Solaris, you need to create these 4 nodes. And you don't only need to connect them in this order, but you also need to tell the last 3 nodes about the node they are connected to. As you can see here, when I select the last 3 nodes and point to the fields where this information about their connected node should go. Now, I should have rendered the scene in 3 layers. 1 layer with the environment, 1 layer with the dropship, the missile and the explosion, and 1 layer with the ground dust simulation. But because the rendering took 1 entire month, or about 3 weeks of non-stop rendering, and because of a Houdini bug that messed up the motion blur of the dropship in the beginning of the shot, I had to render 2 main layers. The dropship and the missile in the beginning of the shot, alone and without motion blur, and the whole environment from start to finish with motion blur. And after the camera turns around, I rendered everything together. By talking to my friends at Chaos, after I rendered the shot, I learned from them how you can separate this shot correctly, with the help of rendered geometry settings nodes. But it is important to know that there is a bug that doesn't allow you to affect any geometry with this node, at least with V-Ray, that is created with the layout node, which is my whole environment. But of course you can work around this by only using non-layout node geometry for the parts of your environment that interact with your hero assets or characters. Here is how I could have separated my shot into the ground dust, the dropship, and the rest of the environment. For the ground dust, I could have used the render geometry settings node's matte shadow features, as you can see here. And in the primitive section, I could have dragged this null node A into this field, reconnect my node tree this way, to have a grid instead of my environment, and the dropship as a holdout for the ground dust. But it is important to know that you should only use a simple shader without any textures for your holdout geo, or no shaders at all if you're using a grid node like I am in this example. I think this is a bug, but at least now you know how to work around it. And that would have left me with the ground dust as my first layer. My second layer would have been the dropship that I could have gotten with another render geometry settings node and the node graph connected to a grid instead of the environment. Because of the bug I talked about earlier, that does not allow the layout node geo to be affected by the render geometry settings node. Here you can see how I could have used the Visibility tab of the Render Geometry Settings node to tell the environment and the ground dust null not to be visible in the primary visibility. That would have left me with the dropship as the second layer. And I could have created the third layer for the environment in a similar way, with a different node graph connection and another Render Geometry Settings node. That would have told the ground dust null node and the dropship null node not to be visible in the primary visibility. The missile with its trail and the explosion could have gone into the dropship layer, or they could have gotten their own layer. But for the sake of this tutorial, I wanted to keep it simple. Here is how all of that would have looked in Nuke, with the environment, the dropship, and the ground dust. In the next tutorial, I'm going to show you how I transformed the look of the scene from this A over B output to the final comp. Alright, that was it for this LoveVFX tutorial. I really hope you liked it. If you want to see some more of these videos, don't forget to subscribe. And if you have any questions, feel free to post them in the comments. Again, this is LoveVFX. Thanks for watching, and goodbye everybody.